Welcome to EDU World Space.
So the problem goes like this. There is a block A which is kept on a smooth surface, and it is also connected to a block over a pulley, block B, which is freely hanging. The spring constant is K equal to 40 Newton per meter, and the distance between the top surface of the block, not the top surface of the block, this is the top surface and the block. This top surface is a support. It is 40 centimeter. So we can see from the diagram this separation is 40 centimeter, and it is given that both the blocks have the same mass, which is 320 grams. Fine. So the initial spring is vertical and unstretched. So this is the initial configuration. Basically this is an initial configuration where the spring is unstretched and vertical. So we will consider a configuration at a later stage. So this is a configuration at a later stage. So in this particular configuration we have this this spring which is stretched, and this block has moved by a distance of L. So this is the distance by which it has moved, and because the block is connected via a rope to this block B, and this rope is unstretchable, therefore this block B also moves by a distance of L downwards. So initially we will do force balance. So initially we will do force balance. Force balance will be done to find out the point at which this block A just is about to leave the surface, so therefore at that particular point the force which is acting vertically will basically balance the force of gravitation. So kx is the force exerted by the spring, and this is the angle theta which is subtended by the spring, which is stretched at an angle because this block is moving towards the right. So the vertical component of the spring force will be kx sine theta, and that will be equal to ma into g, that is the mass force. So kx sine theta is equal to ma into g. We equate this. So we by putting the values in, we get 40, which is the spring constant, into x into 0.4 by 0.4 plus x. So this is basically nothing but sine theta. Sine theta is perpendicular by hypotenuse. Perpendicular is 0.4 meters, and if we assume that the spring is stretched by a distance of x, then this hypotenuse will be 0.4 plus x. We are writing 0.4. That basically means we have converted 40 centimeter into meters, that is 0.4 meter, and now this will be equal to 0.32 kg into 10. This is acceleration due to gravity, so we have converted it into kg. So this will be nothing but 0.32 kg. So that is understandable. Now if we solve this equation, we will finally get x equal to 0.1 meters. Perfect. Now we apply the conservation of energy. Conservation of energy basically means the potential energy decrease due to this block coming down by a distance of L will be equal to the potential energy which is stored into the spring plus the kinetic energy of this block, which is moving by a velocity of v meter per second square. So we will basically do the conservation of energy. mb into g into L, that is the decrease in potential energy, is equal to half kx square, the potential energy due to stretching of spring, plus half ma v square, that is kinetic energy of the block. So substituting all the values, corresponding values, we get this equation. Now in this equation, L is nothing but the distance which is the base of this particular triangle. So if this triangle is M, this point is N, O. So in triangle MNO, the base MN is L. So that is equal to under root of 0.4 plus x whole square minus 0.4 whole square. This is nothing but Pythagoras theorem. So hypotenuse whole square minus one of the side squared will give you the square of the remaining side. So that is what we get. So therefore after solving, this will be 0.3 meters. So this is the value of L. Substituting the value of L into the equation and solving, we get V is equal to under root of 0.76 by 0.16 equal to under root of 19 by 4.